Hello, hi, my dear students. Myself, Desai sir. Today we are going to learn an important chapter in coordinate geometry, class 11th, conic sections. Let us try to understand what is conic section. The meaning of conic section is sections of the cone. What do you mean by sections of the cone? Sections of the cone. You studied cone at the school level. That if you take a cone, this is the cone. Let me take two cones, one above and one below. And if I take this cone, this becomes a double cone. Let us consider a solid double cone. Say, for example, a wooden piece. Assume that it is a wooden piece having the shape of the solid double cone. This is called as solid double cone. Solid double cone. What are the sections of the cone? To understand it, suppose that there are two cones, one is below and another one is above. The point, this particular point is common vertex of both the cone. Let me call it as O. And this upper part is called as upper nap of the solid double cone. And this one is called as lower nap of solid double cone. And this is called as common vertex. Common vertex of the solid double cone. A line which joins the center of the base of both the cones and vertex, this particular line is called as axis of the solid double cone. Axis of the cone, solid double cone. See, what are the sections of the cone? This is called as solid double cone. And how to get sections? To get sections of a particular cone, we have to slice it. Suppose that it is a wooden piece. By taking a blade, hexa blade, you can cut this particular solid double cone like you cut the cake. Similarly, if you cut this solid double cone at different angles with respect to this angle, this particular angle, this angle is called as vertical angle. And if half of this vertical angle is called as semi-vertical angle, let me call it as alpha. Alpha is called as semi-vertical angle. Semi-vertical angle. And we take this semi-vertical angle as a standard to cut this particular solid double cone at different angles with respect to semi-vertical angle. Suppose that I slice this solid double cone, you will get the sections of the cone. We'll try to understand the sections of the cone in the first part geometrically. Geometrically, how we can get the sections of the cone, what are the different sections of the cone, we'll try to understand. Suppose that I slice this particular solid double cone at an angle beta, which is equal to alpha. Say, if I draw a parallel line here, so that these corresponding angles are beta. Suppose that I slice the solid double cone at an angle beta is equal to alpha. Suppose alpha is 30 degree, this will also be 30 degree because I am drawing a parallel line to this particular side. Then whatever, if you slice it, you will get a particular part left behind. That particular part, whatever is observed after cutting this particular solid double cone at an angle beta is equal to alpha. The resultant section of the cone, we call it as parabola. It is called as parabola. Let me draw another cone here, solid double cone. To understand the other sections of the cone, say, this is axis again, and this is semi-vertical angle alpha. Suppose that I slice this solid double cone at an angle beta greater than alpha. If I cut it at an angle beta greater than alpha, say I will cut it like this. Say this is beta. And if you slice it at an angle beta greater than alpha not equal to 90 degree, remember, at an angle beta greater than alpha, then whatever shape you are left with, whatever portion of the double cone you are left with will have the elliptical shape. Therefore, second section of the cone is ellipse. And if I slice the same solid double cone at an angle equal to 90 degree, what will be the shape of it? And if you cut it exactly 90 degree, you can observe a circular shape will be obtained. Therefore, this particular solid double cone, when sliced at an angle beta is equal to 90 degree. Observe, this particular 90 degree is greater than alpha definitely, but in particular when beta is equal to 90 degree, you will get a very popular shape, plane figure, that is called as circle. Means that circle and ellipse are related. Circle is a special case of the ellipse when beta becomes equal to 90 degree. And if I slice, I will take another shape so that you cannot get confused. And another cone I will take. I will slice this time, yes, at an angle beta again with respect to semi-vertical angle, this is alpha. At an angle beta, third case, at an angle beta less than alpha. Suppose this is 30 degree, you have to take this one as this beta as this is alpha, this beta as less than alpha, say 20 degree, 50 degree. Then you can observe that the solid double cone is will slice both to the nappe, upper nappe as well as lower nappe like this. Then whatever shape you are getting, in both the nappe you can expect this particular shape. You can observe here also, you can observe. It will cut the solid double cone at different angles. See, this is beta, which is less than alpha. Then the resultant section of the cone is called as hyperbola. It is called as hyperbola. Like this, there are four sections of the cone. One is called as parabola, in which beta is equal to alpha. Another one is ellipse, and special case of the ellipse is circle, and another one is hyperbola. Means that geometrically you can define a section of a cone are four. The resultant section of the cone are the parts of the cone obtained when a solid double cone is sliced at different angles with respect to semi-vertical angle. Say that angle is beta. If beta is equal to alpha, then the resultant section of the cone obtained is called as parabola. If beta is greater than alpha, the resultant section of the cone is called as ellipse. In particular, when beta is equal to 90 degrees, section of the cone is a circle. Then if beta is less than alpha, means the angle at which you are cutting is less than the semi-vertical angle, then this particular section will cut both upper nappe and lower nappe like this to get another section of the cone called as hyperbola. In this chapter, we are going to derive different equations of the ellipse, parabola, circle, hyperbola analytically. This discussion was geometrical, and can we derive the equation based on their this property called as analytically in coordinate geometry. We are deriving the equation, then we are studying properties of that particular cone in terms of analytically, that is in terms of coordinate geometry. We are going to derive the equations and then we are solving the problems. Let us start with the circle first. And you studied all the plane figures. We will try to understand one by one. First of all, we will see circle, then we will study parabola, then we will study ellipse. Finally, we will be studying the hyperbola.